Okay, Charlotte Ann, so for 14, let's see, you're supposed to use either sine or cosine to find the value of each variable, and then round your answer to the nearest tenth, okay? So what we have for 14 is we're starting out with this 42-degree angle. So, and we know our hypotenuse, right? So remember, no, we're not really using that one today. So both of these use the hypotenuse. Now, if we're looking at the 42-degree angle, the opposite side is C, right? So since the opposite side is C, we can say that the sine of 42 is equal to C over 7, right? And then we just solve that. So then the cosine involves the adjacent side, right? So if we have 42 degrees, D is our adjacent side. So we can say the cosine of 42 equals D over 7. Does that make sense? So on number 18, we talked about this one in class. This is actually supposed to be 39. It just doesn't show up when I pull it over into this app. So we have this 39-degree angle here, right? We know the opposite side, but we don't know the hypotenuse. And then we don't know the adjacent side either. So let's solve for the hypotenuse first. The one that uses opposite and hypotenuse is sine. So we're going to say the sine of 39 is equal to 25 over n. And then solve for n. Does that make sense? Do you see how to solve for n there? Since the variable's on the bottom, you can really just switch these. So you would say n equals 25 divided by sine of 39. And then whatever number you get for n, then you're going to be able to solve for m because you're going to have your hypotenuse. So then you could say the cosine of 39 equals your adjacent, which is m, over your hypotenuse, which comes from there. Does that make sense? Okay. You're welcome. Okay, Isabel, so for number 27, it says you're traveling along a stretch of highway that has a slight grade with an angle of inclination at 5 degrees. So this tiny little angle here is 5, okay? Let me change to a different color. After traveling for 4 miles, what's the vertical V and horizontal H change in feet? And then round your answer to the nearest foot. So for that one, what you have to do is look at your picture. We have our 5-degree angle and we know the hypotenuse, right? So we're going to set up the opposite side over the hypotenuse and then the adjacent side over the hypotenuse. So we can say the sine of 5 equals V over 4. And now when you solve that, you get a really tiny number, right? So what you need to do then, what that gives you is it gives you the decimal part of a mile. So you get that it's 0.349 miles, and you need to figure out how many feet that is. So if you take that and you multiply it by 5280, which is this that's given here, that will give you your answer. Does that help? Is that where you got caught up? Is it was such a small number? So then you'll do the same thing again and say the cosine of 5 equals h over 4. And then again, multiply that by 5280. You're welcome, Isabel. Okay, Charlotte Ann. So for 19, 20, and 21, hang on a second. Let me pull. Let me pull what you're going to need. Okay, so you're going to want to flip back to this page in your book and then the other page in 7.4 that talks about the 30, 60, 90 triangle theorem. Okay, and what it wants you to do is use those to find the sine and the cosine of the angles. So you're going to use this triangle here, all right, and find the sine and the cosine of the 45-degree angle. So the sine of a 45-degree angle is opposite over hypotenuse. So it'll be sine 45 equals opposite over hypotenuse. So those are going to cancel out, and it's going to be 1 over the square root of 2. Remember, you can't have square root of 2 on the bottom, so you have to rationalize it. Square root of 2 over square root of 2. So that's going to give you the square root of 2 over 2. And then you'll do the same thing with that 30, 60, 90 triangle that's like a couple of pages over. You'll look at the 30-degree angle and work that out like that, and look at the 60-degree angle and work that out. And then let's see what other numbers. 22 and 23. Okay, so for 22 and 23, you're supposed to find the unknown side length, then find sine of A, cosine of A in fraction, reduced to simplest form, and as a decimal to 4 places. So the first thing is to find the unknown side length. That didn't really circle the right part. You're going to find the unknown side length. If you know 2 sides to a triangle, how do we find that third side? Or 2 sides to a right triangle, sorry. Yes, Pythagorean theorem. So you've got your a squared and your b squared, so you just have to solve for c squared, right? Or actually for the c. And once you get that side, then you can do the sine of a, which would be the opposite over the hypotenuse. And then you can do the cosine of a, which would be the adjacent over the hypotenuse. Okay? Does that make sense? And then you'll do the same thing for 23, except on 23, you have 14 squared plus b squared equals 50 squared. So you're solving for one of the sides, one of the legs. Okay, so for number 9, Charlotte, for the cosine of y, remember cosine is adjacent over hypotenuse, right? So let me just make a little bit of room to write. Well, that's not helpful. Okay, so the cosine of y is adjacent over hypotenuse, which is 13 square roots of 3 over 26, right? So we can reduce that and say 13 over 26 equals 1/2, right? So that's really just the square root of 3, or sorry, that should be a 3 over 2. Do you see that? So 13 and 26 reduce to be 1 over 2. And then the square root of 3 just stays the same. But because it's just a 1, you don't really have to have that 1 there. Okay. So then I think on those, don't you have to do a decimal? So that you could just put in your calculator as the square root of 3 divided by 2 and see what decimal you get. You're welcome. Okay, Isabel, so for number 28, you lean a 16-foot ladder against the wall. If the ladder makes an angle of 70 degrees with the ground, how far away from the wall is the base of the ladder? And round your answer to the nearest tenth of a foot. So for that one, you're solving for this distance right here, right? So for that, if you look at that 70-degree angle, that side is the adjacent side. And then you're going to be, you're using the 70-degree angle, the adjacent side, and then 16 is your hypotenuse. Okay. So that would be cosine of x equal, or sorry, not x. Cosine of 70 equals adjacent, which is x, over 16. And then that should give you your distance there. And you don't have to do any kind of changing as far as feet to give your answer in the tenth of a foot like you did up here on this one. It was on number 27, you had to do that because it gave this measurement to you in miles, but wanted your answer in feet. This one, your measurement's in feet and it wants your answer in feet. So you're good. There's no conversion to do. Yeah, Madison, hold on just a second. Let me pull that one up. Okay. Okay, so for number 25, you're supposed to find the unknown length of that side of the triangle and then find sine and cosine of A. So first off, if we have two sides of a triangle, how do we find the third side? So if we have two sides of a right triangle, we can use Pythagorean theorem to find the third side, that a squared plus b squared equals c squared. So on this one, your a and your b are your sides, and c squared, remember, is always your hypotenuse. So what we have would be 20 squared plus b squared equals 29 squared, okay? So then to solve for b squared, you're going to subtract 20 squared from 29 squared. Which gives you 441. And then take the square root of that, and that's going to tell you that your b equals 21. Okay. Okay, so then you're good to be able to find sine and cosine from there? Okay, good. Okay, Charlotte Ann, so for number 22, you're supposed to find your unknown side length and then find sine and cosine of x. So remember, to find your unknown side length, you're going to do a squared plus b squared equals c squared, right? So what you have is 7 squared of 3 squared plus b squared equals 14 squared. So you can put this in your calculator, okay? Do you know how to do that? Okay, so to solve for that, you're going to end up with 14 squared minus 7 squared of 3 squared, okay? And then when you take the square root of that, tell me what you get. No, it's not 13.2. So when you do 7 times the square root of 3 squared, tell me what that is. Okay, so in your calculator, try doing it a little differently than trying to type it all in at once. Do the square root of 3 equals. And then multiply that by 7. And then take that answer and square it. No, it should be 147. Did you do that in those steps in the calculator? Okay, so your one side is 147. So then you're going to do 14 squared minus 147. and then the square root of that. And now you're going to use that to do your sine and cosine. Are you good with those parts? Okay. Okay, so the picture is very distorted because it's zoomed way in, and I don't know how to make it not do that. But um, when you're looking at your picture there, the problem says the surveyor measures the angle between the ground and the top of the monument to be 78 degrees. Find the height of the monument. So blue is not going to show up there, so let's change. So he measures from the ground to the top of the monument to be 78 degrees. So then you're going to need to find that length there, okay? He's standing 118 feet away. So does that help? Okay, good. Yeah, let me pull it up real quick. Okay. Madison, for that one, you're going to have to go in your book. Let me see. I've been logged in too long. Let me sign back in and find out what page, okay? You're going to go into section 7.4. And then for number 19, you'll need to find the 30, 60, 90 triangle theorem. It's on page 453. Okay, so then I'm trying to pull it up on the screen. So then what you're going to need to do is it wants you to find the sine and the cosine of that angle, of the 30-degree angle. So if you look at that triangle there, excuse me, and focus just on the 30-degree angle for number 19, right? You're going to go, the sine of this 30-degree angle is opposite over hypotenuse. So opposite over hypotenuse. So it'd be the sine of 30 equals x over 2x. Those x's cancel, so it equals 1/2. Okay. And then the cosine of 30 equals adjacent over hypotenuse. So x squared of 3 over 2x. Those x's are going to reduce, and it's going to equal, I always write a 2 instead of a 3. It's going to equal square root of 3 over 2. Does that make sense? So then you'll do the same thing with that triangle for the 60-degree angle, okay? You'll go from 60 and say the sine is opposite over hypotenuse, and then the cosine is adjacent over hypotenuse. And then for the 45, 45 also. You're welcome. Hey, Isabel, is this making sense to you since you weren't there yesterday? Okay, good. All right, any other questions? Okay, I'm going to sign off then, okay? Just email me if you have some questions, Isabel.